Hi everyone. In this video we're going to be working on the 2014 AP Calculus AB free response question number 6. This question happens to be one of the easier ones out of the 6 of 2014, except that letter C happens to be the one that's worth the most points. C was worth 6 points. So if you couldn't answer C or didn't have enough time to get to C, you lost a bunch of points just because of time. So what's going to happen is we're going to read through the question. I'm going to look for keywords. I'm going to let you know, and then you'll notice this chart. This is called a slope field because at every single point it's a different slope. So we're going to read the question. It says, consider the differential equation dy over dx is equal to 3 minus y cosine x. Let y equal f of x be the particular solution to the differential equation with the initial condition f of 0 equals 1. The function f is defined for all real numbers. A portion of the slope field has a differential equation is given below. Sketch the solution curve through the point 0, 1. So keyword, they want us to sketch a solution, but it has to pass through 0, 1. Well, 0, 1 is right here. And the most important thing is you have to look at the slope. I don't know if you're able to see, but the slope of this line is a positive direction. So it wants us to pass through this point, but in a positive direction. So this is where you have to go, okay, well, the curve's going up, so and all of these are going up, so I'm just going to follow it. It's starting to turn, and then it starts to go down, and it looks something like this. Then the same thing on the other side, it's going down, and then it's starting to turn, and it ends up looking something like that. Now, if you have something similar to that, you got the point for it. So moving on to question B, to letter B, it says, write an equation of the line tangent to the solution curve in part A. Well, right there, write an equation tangent. That means automatically y minus y1 is equal to m parentheses x minus x1. That's the first thing I think about when I see tangent. At point 0, 1. These are your points. This is x1, y1. Only thing we're missing is that m. How do we find that m? You got to find the slope. So then it tells you use the equation to approximate f of 0.2. I'm going to work on that afterwards. I need to first figure out my tangent line. Well, m is your derivative, your slope. Well, luckily they gave me my derivative. So I'm going to go ahead and plug that in, and I'm going to do it over here. So this is part B. dy over dx is equal to 3 minus 1 cosine of 0. And then my next thing I'm going to do is just work it out. Well, 2 cosine of 0, remember what cosine of 0 was? Which is 1, so 2 times 1, which equals to 2. Which means that my slope was 2, so when I create my tangent line, y minus 1 is equal to 2 parentheses x minus 0. And then I'm going to work that out, and that's going to give me y equals to 2x plus 1. This is my tangent line right here. So just being able to get that tangent line, you're going to get yourself a point, and the next thing is you got to figure out the approximation. Well, the approximation is they want you to find f of 0.2 of this equation, which is the tangent line. So I'm going to take that f of 0.2 and plug it in. Y equals to 2 times 0.2 plus 1. Just solve it, and you're going to get y is equal to 1.4. That's the approximation using the tangent line. And if you were to be able to get that answer, that's your second point. So that right there, from part A to part B, gives you 3 points. Now, the real killer is part C. Anytime you see this question, by the way, you'll notice it has an x and a y. So that meant that you had to use differential equations, which means you're going to have to do implicit differentiation in respect to x and respect to y. So what I'm going to do is I'm going to take this on the other sheet. It says, find y equals f of x, the particular solution to differential equation with initial condition f of 0 equals 1. So they want us to find the antiderivative of this, and then knowing that the c is going to be this one. So then I'm going to take this to another paper, and we're going to go ahead and actually work this out. So when you have an equation, and then remember, this part of the question is worth 6 points. Every step matters. I can't stress that enough. Every step matters. When you have dy over dx, and this is equal to 3 minus y cosine of x, the first thing you have to do when you're working with implicit differentiation, you have to separate the y's and the x's. get the y's on the left side, get the x's on the right side. Every single time. Meaning, I'm going to bring this over here so that I have dy is equal to 3 minus y cosine is x dx, which is good, but I can't have a y and an x, so I'm going to bring this over here. This comes to become dy over 3 minus y equals to cosine x dx. Then my next step is, once I'm able to separate all of that, which if you're able to separate it you get a point, I'm going to go ahead and find the antiderivative. Well, you'll notice the antiderivative, this is a fraction, which means u substitution. Antiderivative of cosine, you should already know, is sine, so you get a point for knowing the right side. But the left side is where, if you're able to get that, you're going to get a lot of points. Well, because it's a fraction, u substitution, u is equal to 3 minus y, du over dy, because respect to y, is equal to negative 1, solve for dy is equal to negative du, and then plug it in. 1 over u, negative du, is equal to antiderivative of cosine x dx. Take this negative to the outside, and I'm going to do kind of two steps. I'm going to take this negative to the outside and ask yourself, what is the antiderivative of 1 over u? Hopefully you said negative ln absolute value u equals to antiderivative of cosine, which is sine x plus c. And then the next thing I'm going to do is, well, I don't want u anymore. I actually want to figure out what u was. U was 3 minus y, so I'm going to plug that back in. Negative ln absolute value 3 minus y equals sine x plus c. And if you were able to get this step right here, the antiderivative for both sides, you got yourself another 2 points. Now, what I would do next is, remember that initial condition? They told you to find the initial condition f of 0 equals to 1. They gave you that because you wanted to find this c. So just go ahead and plug this point into here. Negative ln absolute value 3 minus 1 equals sine of 0 plus c. Negative ln 3 minus 1, so negative ln 2, which I don't have to put the absolute values because it's a positive number, equals to sine of 0, and you have to know sine of 0 is just equal to 0. So this is equal to c. This is what c is equal to. If you're able to get that c, that's another point. Then your next step is, I'm going to take this equation and plug it into here. So that's going to give me negative ln 3 minus y equals to sine x minus ln 2. And then now, if you're able to get that, you just got 8 out of the 9 points. If you're able to get this far. The last point is, can you solve for that y? If you can, great, you get an extra point. But if not, at least you got 8 points if you happen to get part A, part B, and then 5 out of the 6 points for part C. So now solving for that y. Well, the first thing, I want to get rid of that negative, so I'm going to divide by negative to both sides. Divide by negative to everything. So ln absolute value 3 minus y is equal to negative sine x plus ln 2. Then my next step is, okay, I want to get rid of the ln because I need y by itself. Apply e to both sides, so that cancels it out. That leaves me with 3 minus y equals to e to negative sine x plus ln 2, all in the exponent of e. And then you got to remember the rule that whenever you have e and you see two things being added, you got to separate it. So 3 minus y equals to e to the negative sine x times e to the ln 2. When you separate it, you're multiplying, because when you have the same bases, you have to add the exponents, which is what we have above. Then you have to go, well, e to the ln, what happens? Cancels out. So this 2 drops down, so you have 3 minus y equals to e to the negative sine x times 2, and then bring that 2 in front of the e. So 3 minus y equals to 2 e to the negative sine x. And then to solve for y, subtract by 3. And then divide by negative 1. And this right here is your particular solution with the initial condition f of 0 equals 1. So all of this solving for y was worth 1 point. If you get it, great. If you don't, it's okay, but hopefully you'll at least be able to get 8 out of the 9 points. Alright guys, thanks for watching. Hope it helped, and good luck.